The electronic concept conveniently explains the redox reactions in terms of transfer of electrons from one species to the other. Let us see how. While the classical concept defines oxidation in terms of addition or removal of elements, the electronic concept defines it as loss of electrons. In a chemical reaction, during the formation of products from the reactants, the loss of electrons results in the increase of positive charge or decrease of negative charge of the species. We know that reduction is the opposite of oxidation. The classical concept defines that too in terms of addition or removal of elements. The electronic concept defines it as gain of electrons. The gain of electrons results in the decrease of positive charge or increase of negative charge of the species as we proceed from reactants to the products in a chemical reaction. Thus, according to electronic concept, a reaction in which loss of electrons, that is, oxidation and gain of electrons, that is, reduction, takes place simultaneously, is called redox reaction. The definition of oxidation and reduction can be easily remembered by the mnemonic OILREG, which stands for oxidation is loss of electrons and reduction is gain of electrons. Let's take the example of the formation of sodium chloride from sodium and chlorine. In this reaction, sodium loses an electron and forms Na+ ion, while chlorine gains an electron and forms Cl- ion. Hence, according to electronic concept, sodium is said to be oxidized, whereas chlorine is said to be reduced. The part of the reaction that involves loss of electrons is called oxidation half reaction, while the part that involves gain of electrons is called reduction half reaction. The sum of the half reactions gives us the complete redox reaction. In a redox reaction, the substance that donates electrons to reduce the other substance is known as a reducing agent. On the other hand, the substance that accepts electrons to oxidize another substance is known as an oxidizing agent. In this process, the reducing agent gets oxidized and oxidizing agent gets reduced. Thus, in the reaction between sodium and chlorine to form sodium chloride, sodium acts as a reducing agent by donating the electrons, while chlorine acts as an oxidizing agent by accepting the electrons. We know that metals show the tendency to lose electrons. The more easily a metal loses electrons, the more active it is. Let's try to understand this through the following activity. We have placed a zinc rod in an aqueous solution of copper nitrate. Let's observe what happens. After a while, we notice a reddish coating which is due to the deposition of metallic copper appearing on the rod. We also notice that the intensity of the blue color of copper nitrate decreases and becomes colorless after some time. This is due to the disappearance of Cu+2 ions, which are responsible for the blue color of the solution. Let's look at the chemical equation to understand what happened. In the reaction, zinc lost electrons to form Zn2 plus ions. Therefore, zinc was oxidized. Simultaneously, Cu plus 2 ion was reduced to metallic copper as it gained electrons from zinc. Thus, we can conclude that zinc releases electrons to copper. Now let's place a copper rod in zinc sulfate solution and see if we get the same result. After a while, we notice that no reaction has occurred. We can confirm the same by passing hydrogen sulfide gas through the solution. If copper ions were present, a black precipitate of cupric sulfide would have appeared. Thus, we can conclude that copper does not release electrons to zinc. Now, let's extend the electron transfer reaction to copper metal and silver nitrate solution in water. Let's place a copper rod in an aqueous solution of silver nitrate and leave it undisturbed for some time. After a while, we notice that the solution has turned blue due to the release of copper ions from the copper rod into the solution. We also notice the deposition of metallic silver on the copper rod. In this reaction, copper is oxidized to Cu2 plus ion and silver ion is reduced to metallic silver. This shows that copper releases electrons to silver. From the above experiments, we can conclude that among the three elements, zinc, copper and silver, zinc has the greater tendency to release electrons than copper and silver. This suggests that metals differ in their tendency to release electrons. Depending on the tendency of the metals to release electrons, metals are arranged in the form of a series. The series obtained when the metals are arranged in the decreasing order of their ability to donate electrons is known as metal activity series or electrochemical series. Thus, the knowledge of competition between the metals to release the electrons helps us to construct galvanic cells in which the chemical energy is converted into electrical energy.